Hi, today we're going to be talking about one other important topic about triangles: interior and exterior angles. These are some properties that are unique to triangles, and they're pretty interesting, and they can help you solve some pretty difficult problems. So, in a previous lesson, when we were first talking about triangles, we said there were a couple rules related to them. One of them was the sum of all the angles in a triangle is going to be 180 degrees for every single triangle you can draw. But why exactly is that? Now, I know I didn't have a rock-solid proof. I just said this is the way it is. But today, we're going to prove that that has to be true. That the sum of the angles in every single triangle possible is always going to be 180 degrees. And along the way, we're going to figure out some new properties about interior and exterior angles. So, let's start with the proof. I have this nice triangle right here, and I'm going to prove that these angles, adding them together, will always be 180 degrees. So I'm going to make no assumptions about how long these sides are, what their lengths are, or if they have a relationship. I'm just going to start by drawing a line. And I'm going to say this line is parallel to this line right here. Now, we know that parallel lines mean that they will never ever intersect. Now, what's the point in doing that? Well, the point is I've created some more angles. I'm going to label these A and B. I've created them along with my original line, which I'm actually going to title 1, 2, and 3. And here's where my proof comes in. We know by alternate interior angles, we learn with dealing with parallel lines, that angle A is going to be equal to angle 1, and angle B is going to be equal to angle 3. Now, why on earth is that useful? Well, if you agree, this whole angle right here, or angle A plus angle 2 plus angle B, has to be equal to 180 degrees. This is a flat line, and we know the measure of a circle is 360 degrees, so 1/2 of that, a flat line, is going to be 180 degrees. We know that for a fact. But since we know that this is true and this is true, we can substitute angle 1 for angle A and angle 3 for angle B. And so then we have angle 1 plus angle 2 plus angle 3 equals 180 degrees. And just like that, we've proved for any triangle, the sum of these angles has to be equal to 180 degrees. So, that was cool. But what does that have to do with interior and exterior angles? Well, when working with that proof, those angles inside the triangle were all interior angles. And that's cool. We have a lot of properties that we can work with those. We, in fact, use the interior angle property to continue solving them, the alternate interior angles. But what about exterior angles? Where do those exterior angles come in? Well, they start by saying, what happens if we're dealing with something outside of our triangle? What if I have a triangle here, nice and friendly, and I say, what's this angle here? This is what we call an exterior angle. And at first glance, you may say, how on earth am I supposed to solve this? I know that some of the angles inside the triangle are 180 degrees, but that's about as much as I know. Well, here's how you solve these types of problems. You say, hey, this whole thing, this line the exterior angle is a part of, is an extension of this line in the triangle. So if I were to draw this out, if I were to erase this, I really have, this is my exterior angle, and this is my triangle angle. I'm going to call it, angle C. Right? And we notice here, and we say, hey, this is a straight line. So we know angle C plus this mystery angle has to be 180 degrees. Just like earlier, flat line, measure of it entirely, that's 180 degrees. So our question, our mystery angle, our exterior angle is always going to be 180 minus this measure of the corresponding triangle. All right, so anytime you have an exterior angle, let's say I'm given this and I say, find this exterior angle. It's just going to be 180 minus the angle here. If I have an exterior angle here, it's going to be 180 minus the angle here. Now, sometimes you won't be given the angle here. To give you an example, I might have a triangle like this. I might have it say, this is 30 degrees, this is 50 degrees, and I want to find the exterior angle here. Well, I can't do 180 minus this. I don't know what this is. But think about it this way. If we were given this original triangle, we know that the sum of the angles inside this triangle are 180 degrees. So 180 is equal to angle C plus 50 plus 30. So we could solve for C. We say angle C is 80 equals 8, and subtract 180, we get C is equal to 100. We say, oh, then this angle has to be 180 minus 100, which equals 80. Boom, we solved our answer. But that's a lot of calculations. Instead, we can say that this mystery angle is equal to the sum of the other two angles inside our triangle. Well, why is that? Think about the original triangle equation, right? 180 equals angle 1 plus angle 2 plus angle 3. Well, 180 minus angle 3, let's call this angle 3, is the formula for an exterior angle. So therefore, it's equal to the sum of the other two angles in the triangle. So instead of doing, basically two equations, double the math, we can look and say, oh, well, going by this property, this exterior angle is equal to the sum of the other two interior angles inside my triangle. So this exterior angle is equal to 50 plus 30, or 80. And that's how we find that answer. So that was exterior and interior angles. Good properties to know, good properties to work with, and they'll pop up a lot more in shapes beyond the triangle. Because that's right, we're going to more shapes beyond our simple triangle. We're going to the next level. So thank you for watching. I hope this helped, and I hope you have a great day.